Very good morning. Myself Morgan, Assistant Professor, Department of Agriculture Engineering, Sri Shanmugha College of Engineering and Technology. Today we're going to see about open channel flow. Uh, I think this open channel flow is most suitable for the agriculture engineering student as well as civil engineering. So now we're going to see about what is open channel flow and what are the things that is available in the open channel flow. And we just see about the clear and practical applications of open channel flow across engineering, environmental science, and real world infrastructure. So let me go with the first. What is open channel? So it refers to the movement of liquid with free surface exposed to the atmosphere. This happens when the flows are driven mainly by gravity, not by pressure differences. Water in river, canal, drain, a stream, natural stream, all behave as an open channel. The channel either it may be of rectangular, triangular, trapezoidal, circular, the bed slope, the surface roughness, the depth of flow that influence how the water is moves from one place to another place. As we are engineers, that we analyze open channel flow to determine the velocity, discharge, flow depth in hydraulic structures. It plays a major role in irrigation, flood control, stormwater management, hydropower, and wastewater transport. So it's a flow with a free surface which is exposed to atmospheric pressure. Let me see the circular, the pipe flow full means under hydraulic pressure. So these are some common typical applications of open channel flow: irrigation system, drainage and flood control, river and stream engineering, hydropower generation, water supply and distribution, wastewater and sewer system, design of hydraulic structures. Some of the field applications of open channel flow that we have used in agricultural irrigation channel, agricultural field drainage. That means we want to create that open channel for draining out the excess water which is available in the field. River engineering and flood control, watershed and runoff management, farm pond and water harvesting structures, canal and drain maintenance, aquaculture and fish farming, rural and semi-urban drainage system, on-farm water measurement and management. And now we're going to see about the basic things like what are the types of channels available in open channel flow and what are the types of flow, velocity distribution, discharge through open channel, and let me go with most economical section. Specific energy and specific energy curve, hydraulic jump, and gradually varied flow. So these are the some learning objectives that we're going to discuss one by one in future. So let me see the types of channel. The open channel is a flow which has free surface and flows due to gravity. Pipe not flowing full also fall into a category of open channel. In open channel, the flows are driven by a slope of the channel rather than the pressure. Here in open channel flow, the gravity plays a predominant role rather than the pressure. In pipe flow, the uh, pressure, I think the external pressure which is required to send the water from one end to the other end. So in open channel flow, gravity plays a predominant, as well as in the pipe flow, external pressure is a predominant role. So open channel flow has been classified into the four category. So one is about the natural channel and artificial channel. So natural channel, it has irregular shape, but artificial channel, we have a regular and defined shape. Example for natural channel, a river, hillsides, tidal estuaries. In case of artificial channel, drain, culvert, sewer, and tunnel. So under this we have a category comparisons between open channel and pipe flow. Already we talk about the open channel flow is mainly due to gravitational force. Pipe flow is mainly due to the pressure. So here in open channel flow, the fluid number which governs the flow. In here, in case of pipe flow, the Reynolds number. Here, the pipe flow, it's completely deals with the viscosity of the fluid. Here in the fluid flow, it's completely Froude number which is directly proportional to velocity of the flow and inversely proportional to the depth of flow. But here the Reynolds number which is directly proportional to density of the fluid, velocity of the fluid and diameter of the fluid, but inversely proportional to the viscosity. So here in open channel flow, the Froude number which governs the flow. In pipe flow, Reynolds number which governs the flow. Here in case of open channel flow, Reynolds number is less than 500. So the flow can be called it as laminar flow. If the Reynolds number is greater than 2000, turbulent flow. In between 500 to 2000, the flow is called transition flow. Here in case of pipe flow, Reynolds number is less than 2000. We can say it is called as laminar flow. Reynolds number greater than 2800, we can say turbulent flow. The lines between 2000 to 2800, we can say it is called as transition flow. In case of open channel flow, the slope of the bed may or may not be constant. For example, river, so start from one place and end at the one other place. So in between the length of the river, the channel slope, it may be vary from place to place depending upon erosions. So the slope may or may not be constant. Here in case of pipe flow, we defined the pipeline as well as channel. So here the slope of the bed is constant and the cross section, it may vary. Cross section either it seems here is length and means width and depth of the channel. It's really to be varied for in case of open channel, but in case of pipe flow, it is uniform. In open channel flow, friction may vary with length. In pipe flow, friction is a function of material and time. So these are the types of channel. Before getting to this type of channel, it has been classified based on with variations with the time, variations along the channel length, variations along the depth change based on the Froude number. This is for types of flow, and now we're going to see about the types of channel. We've been classified into natural channel, artificial channel, open channel, closed or covered channel, prismatic and non-prismatic channel. These are the types of channel according to open channel flow. Let me see one by one. Natural channel, which has irregular shape of section of varying shapes developed in natural way. The best example of natural channel is a river. An artificial channel, it has built artificially for carrying the water for various purposes, especially a sewer line. It comes under the category of artificial channel. And the canals, it is an artificial channel. The cross sections of such channels are regular, geometrical shape, which usually remain same throughout the length of channel. Open channel, a channel without having any cover at the top, is known as an open channel. Example is an irrigation channel. Closed, a channel having a cover at the top, that is pipe or underground drains, or we can say closed or covered channel. Prismatic, a channel in which the cross-sectional shape and size, also the bottom slope are constant, is termed as prismatic. Examples or man-made channels are called prismatic channel. And non-prismatic, all natural channels generally having varying cross-sections are termed as non-prismatic channel. Rigid, in which the boundary is not deformable, that is the slope, shape, bed slope, roughness, magnitude or not be the functions of such flow parameters. Examples of lined canal and sewers, because here in lined canal and sewer, all the sites have been completely covered with either ether material or it may be masonry structures. Mobile boundary channels are those on which boundary in deformations due to fluid flow. The deformations of boundary occurs due to continuous erosion and depositions of sediment. And now already we discussed, they have been classified into 4 categories. One is based on the variations of time. Here in variations of time, it has been classified with steady and unsteady. Based on the variations along the channel length, it has been classified into uniform and non-uniform. Based on the rate of depth change, it has been classified into gradually varied and rapidly varied. Under this case, we have been classified into laminar and turbulent. Based on Froude number, we have been categorizing the flow as subcritical, supercritical, and critical flow. Steady flow. Here in case of steady flow, the flow parameters such as depth, velocity, discharge, it does not change with respect to time. An example of steady flow is a water which is flowing in the canal with a constant discharge. Unsteady flow, flow parameters, depth, discharge, velocity, it may change with respect to time. Example, flow waves, that means flood waves in a river during rainfall. Next one is based on the variations along the channel length. It has been classified into two types. One is uniform and non-uniform. In uniform flow, depth and velocity remains constant along the length of channel. An example for it, a long straight channel with a constant bed slope. Non-uniform, the depth and velocity change along the channel. Example is flow approaching a dam or a weir. The next one is about the gradually varied flow. Here the depth changes very slowly along the channel. I think you guys have seen the gradually varied flow diagram, how this Y1 and Y2. So because of any weir or any slope that have constructed across the river, the depth of the flow, it tends to changes very slowly along the length of the channel. An example, the backwater curve upstream of a dam, rapidly varied flow. The change takes place very suddenly over a short distance. The best example of rapidly varied flow is about hydraulic jump. In spatially varied flow, if the variation occurs due to addition or obstructions from the same flow, the flow is called as spatially varied flow. This is about the classifications of open channel flow based on fluid number. So it has been classified with respect to fluid number. The fluid number is the inertial, the ratio between the velocity to the depth of flow. So it has been classified. If the fluid number is less than 1, the flow is called subcritical. Example is deep river flow. Here in case of gravity force will be dominant. In case of critical flow, here in this critical flow, the fluid number is equal to 1. In such cases, the minimum specific energy conditions will come. In case of supercritical flow, fluid number is greater than 1. Here the shallow, fast flow. Here in case of supercritical flow, inertial force will dominate. An example, spillway, flows in spillway, flow in steep slopes. So these are the some types of flow as per for subcritical to supercritical, supercritical to subcritical. So next is about the velocity distribution. The velocity is always may vary across the channel because of friction along the boundary. The maximum velocity is usually found just below the surface. This is about the velocity distributions across the section, and the one is about triangular section, how the velocity profiles tend to change. The second one is about circular section, how this velocity profile is getting distributed. The third section is about trapezoidal. Here in case of how the shear stress as well as velocity, it is getting distributed throughout the section. Next, we'll look into some of the basic definitions about depth of flow. The vertical distance between the free surface and the bed of channel, it's called depth of flow. Top width, the width of liquid surface which is exposed to the atmospheric pressure. I'm just taking this example for a trapezoidal section. The top width for the trapezoidal section is B plus ND, the side slope ND plus ND. We'll add in together, we'll get B plus 2 ND. This is for vectored A perimeter. We can say the vectored perimeter is a cross-sectional area of the section. Area for rectangular BD, area for trapezoidal, B plus ND into D. This is for the vectored perimeter. The vectored perimeter called the water touched portions in the section. We can say that is called as vectored perimeter. It is a length of channel boundary which is in contact with flowing water. Next, we'll move on to hydraulic radius. The ratio between area and the perimeter, we will get the hydraulic radius. It is indicated by the symbol M. Hydraulic radius for rectangular section is d by 2. For trapezoidal section is d by 2. For triangular section is d by 2 square root 2. Hydraulic depth, the ratio between area to the top width of channel. For top width, rectangular is for bottom and top width for rectangular section is same. But in trapezoidal, bottom width as well as top width is little varying. In bottom width is very less rather than the top width. It is want to carry out more amount of water, that is discharge is maximum. Let me go with this trapezoidal section. Bed slope, you know that the slope of the channel I is equal to the head loss divided by the length of the channel. and discharge through open channel. So we're going to calculate the discharge for the open channel with respect to the following equations by using of chassis, by using of Mannings, and by using of basins, and by using of scooters. We're going to calculate the discharge of the open channel flow. So thank you. So we will discuss the remaining in further classes. Thank you, everyone.